Okay, good morning. Welcome to
FamilyMath1090.
FamilyMath1090. So we just listened to Peter Rolad and Katie Steckles talking about the Rubik's Cube on the Mathematical Objects podcast, and I asked you both to write down a couple of things you thought were interesting, so why don't you go?
Alright, first the podcast was about how the Rubik's Cube is a mathematical object and how it's part of group theory.
Okay.
So they sort of defined what a group was. What is a group? That was pretty neat because I didn't know what a group was before this.
All right. So what is a group? What did they say were the requirements for being for an object being a group?
So what you do is a group is a collection of things, objects, and if you use an operation and you use the operation and combine two of the elements in your group, you get another element in your group.
Okay.
So one example they gave was the set of integers.
All right.
So if you add any two integers, you're going to get another integer.
All right. Yep, that's right.
And they also said the groups have sort of a zero to them, where if you use the operation, it doesn't change. Like the second thing, it doesn't change it.
Okay, what's the example? Write it out, the example of the zero when you're talking about the group of integers.
Well, it's zero because if you take any element in your set, say 6, and you add 0 to it, it doesn't change.
Yep. Okay.
And then sometimes groups have inverses.
In fact, always.
Yeah.
That's one of the requirements, that you have an inverse. And what does it mean to be the inverse?
So when you take any element in the group and you use your operation on it, so the inverse of 6 would be minus 6. So minus 6, you get your 0.
Yeah, now here's a tricky thing though, but you said the operation was plus. So now you're introducing this new operation called minus. So what if we just have what's our plus operator do?
6, I guess it would be 6 plus minus 6.
Yeah, that's right. Okay, good. So that's one thing you thought was interesting. Why don't you go now, and then we'll talk about a few things. What's something you thought was interesting?
I thought it was interesting tying the group into how the Rubik's Cube works. So the Rubik's Cube, they thought of the Rubik's Cube as a group of states, they called them, where each state is an arrangement of squares in the Rubik's Cube. And that's a group of, I think they said 43 trillion states.
Yeah, I don't know the exact number. I thought it was maybe even bigger than that. But it's fine. It's a huge number of states.
Yeah. But it still works as a functioning group. There's the I think it's called the identity element, where this works. You do nothing to it.
Okay.
You have inverse elements if you go up and then go down.
Yep.
I think another requirement for being a group was it has to be associative.
That's right.
So I think that works, but it doesn't have to be commutative. Like if you do up and then over, that's different from doing over and then up.
Yeah. Now go. Let's. Are these two cubes the same? So I'll put yours.
Yeah.
Okay. So you do one.
And do up and then over.
And then I'll do over and up, and we can see that in fact those really are different states of the cube. But that's okay in a group.
Yeah.
That's okay. So non-commutative is okay, but it will require the group to be associative.
Yes.
Okay.
Yeah, and then it was interesting that in a group, what usually happens, or maybe what always happens, is that if you add the same element, like if you have an element X and you add that to itself or combine it with itself a bunch of times, you're gonna eventually get back to the identity element.
Okay.
Yeah. So
And that works for any move or combination of moves you do on a Rubik's Cube. If you do that some number of times, it might be like 1,000 times, but some number of times it'll get you back to this if you start here.
Yeah, that was a good demonstration. Another like slightly more complicated one is the up back move that we were just talking about. I'll do it so the colors are so you go over, just keep doing this, up and back, up and back, up and back, and I get turned to where I started.
But you could do like 100 move combination, and if you just repeated that,
Yeah.
it would get you back to the identity.
Okay, cool. All right, well, let's talk about some of these things in a little bit more detail.